So we just took down and broke apart the entire infrastructure for the NahamCon CTF, and looking at the stats, I'm kind of shocked, but also not really shocked and surprised that a lot of people were not able to solve the NahamCon mission. If you're not familiar and this is your first time watching one of my videos, NahamCon is a conference that I host every year, and almost every year we do this thing called a mission, and the mission is supposed to be like a very much realistic approach to a bug bounty CTF, where we showcase a lot of vulnerabilities based on write-ups or friends talking about it or life hacking events and so on. So a lot of these different aspects are based on real life, except for maybe one or two that's just making you think about things. And I want to preface all this before we go into the video so I don't get a lot of comments saying, hey, this is not realistic. It is realistic. It just, you have to piece them together in order to understand them. So I figured, why not do a video and do a walkthrough. I'm not going to solve the entire thing, but I'm going to solve the more easy and the things that I think people got stuck, and talk about why people got stuck. And maybe this gives you a little bit of understanding with bug bounties and maybe my even approach of doing web app hacking that could be very useful when you approach a real target. As always, if you want to follow along, all you have to do, this is 100% free. Go to hackinghub.io, make an account, look for the NahamCon CTF or NahamCon mission, and follow along. It's free. I'll also link it down below in the description. And throughout the CTF or the solution for it, do me a favor, drop me comments and let me know what you think. Are these realistic, or have you seen any of these in the wild or exploited them? I want to hear from you, but let's jump into it really quickly and see what this CTF is about. So the first thing you're going to see when you launch this mission is this application is going to take you this app/login, and it's just going to show you with this small application that takes a registration. If you want to register for an account, we're just going to make a real quick one. It's going to just come back and say, hey, this is actually not a acceptable domain, and you can only sign up with nahamcon.ctf, which this domain, even if you did own it or you could get emails sent to it, it wasn't usable. The whole point was to kind of block you from getting an account on this specific site and make you think about the different ways that you can approach a website. One of the things that's very, very common when it comes down to signing up for these functionalities, especially with bug bounties, is you're not going to be able to easily get in, but once you get in, there are a ton of vulnerabilities. And when I say this is a really, really large portion of a lot of my bounties, is just spending the time to find an asset where not everybody can register, but you find a way to hack your way into it. In this case, you couldn't just simply register. There was no bypasses for this nahamcon.ctf. You couldn't use any tricks like typing in an email and maybe doing CTF or actually nahamcon.ctf. A site you'd control. The site.com could be your domain. Things like that wouldn't work. What you had to do was maybe just look around a little bit, and one of the most obvious answers is usually looking at robots.txt, maybe doing some recon in the real world and finding a similar application. And again, this is based on a true story actually, and going in here and looking at the dev version of this site where it allows you to register for your own actual domain or actual email address. So if I type in here xnahamsec@gmail.com and give it a password, actually we have to register for it. So if I do that again, it is going to come back and say, look, we are going to give you an account, but except with this account that we're giving, let me pull this right here. With this account, what you're going to see here is that you don't have access to any dashboards or anything like that because we're running some maintenance. In a real world, this could be an application that you can hack on, but you can also abuse some of these functionalities to kind of learn what the application is about. Maybe you can find all the routes that are behind this thing. Maybe you can find the API calls and so on, and kind of just tie them back into the main application. However, that was not the case here, and I'm going to show you what that was really quick. We're going to launch our Kaido or whatever proxy tools you use. I'm using Kaido for this example, but what you would do here is attention to small details and looking at this logout functionality, because a lot of times what I've noticed is when you first run an API, you're hacking on an application that you pretty much have no understanding of what's there. Maybe it's an API, for example. A lot of times logout is one of the most common endpoints that you can hit. But now if we start queuing our proxy, we send this logout request and send it to our repeater and just observe the response for it, we can see that it's coming back and it's deleting our dev token, which is how we're authenticating to this application. It's saying it's now deleted, and the whole point here was for you to go, I wonder if I can reuse this token and log into the application. Well, the answer was no, and also kind of yes, because you can, but there's a trick to it. If you were to actually remove this and say, hey, I want to go to app, for example, with this login, with this exact dev token, it wouldn't work because you don't have the right cookie header. It didn't actually work because this is for the dev token. This is for the dev site. But if you were to hit the logout on this, and observe the header that is coming back. You can see that the token for prod is the name of the cookie for this application. So all you have to do was swap out a actual session and assign that session cookie that you have to token for prod instead of the dev token. And if you send this out to the app, it should work. If not, you may have to actually create a new session and it will help you log in, which it looks like we may have actually been able to log in. So what I'm going to do now here is I'm going to copy this and I'm going to stop. I'm going to go back to our main app. We're going to hit login and we're just going to refresh. We're going to send this out to it and we're going to see what it does. And now we can see that it's logged us in. If we refresh this, and I'm going to actually just do app API me. And if I send this request with this token, now we have been logged in as a user and it's giving us the flag. But what's important here to note is you can see that you're logged in as Patricia Jones, which means that ID 6 on prod, it is the same as ID 6, which is our account on the dev side. So in reality, if we keep on creating more and more usernames, if we make another account, ID 7 is going to be the next one, ID 8, 9, 10, 11, 12, and we get to take over every single one of those accounts as long as we keep on registering a new account and logging into it and creating a session on the dev side. So that was the whole trick of getting an account to be able to log in to the site and then kind of playing around with the rest of the site to be able to actually find a vulnerability that takes you to the next spot. So that was the first step, and you can actually do something like users here. If you did a get users, it would come back and say not found, but if you made a post request, actually this is supposed to be get users. Let me do that one more time. If we do a get users, it should come back and say forbidden, you're not permitted to see this. And we call this postman, so it can give you a hint that you're supposed to do post. And if you go to post request here, you can see that it actually leagues all the different users in their role. So now you can see here that if you go down here, ID 14 is an admin. We can actually search for this and see who's all an admin. And it looks like ID 37 is not disabled and is an admin versus the other account right here, ID 14, Jessica Lee, is an admin, but the account was disabled. So if we take over number 14, it's not really useful. So you have to keep on repeating this until we get to the ID that we want. I'm actually going to copy this into jwt.io. We're going to go over here. We're going to toss it in there, and we can see that right now we're in ID 6. We don't have the secret for it, so we can't re-sign this and just maybe renaming this or editing that to ID 7 or ID 8 or ID 4, whatever the number is. But what we can do is we can just keep on going to this dev site and creating a username until it gives us what we want. So what I'm going to do here really quickly is I'm going to register and send this request to our repeater. And what you have to do here is you want to send this, actually register. You want to look at this. You can automate this in a number of different ways. You can do it with Python. You can do it with whatever app you want. But the whole story here is you want to keep sending this request with a new email address until the account is created. So we can actually do this with maybe an integer, whatever it is, use Intruder, whatever tool you have, and do it until you get to this ID that we wanted, which is our ID number 37. So what you can do, whether you're using Intruder with Burp Suite or you want to use Kaido, you can actually automate this using the automate tab of Kaido and say, hey, I'm going to mark right here, I put a number 1, so it's X1, and it's going to throw these numbers instead of the 1 right there, and it's going to register us every time. So once I start this, it's going to start hitting the register for us, and every time the new registration happens, it's going to give us a new token. So we want to do this all the way till we get to the user ID number 37, and I think I need to do 15 more, so I'm going to go back to automate. We're going to take a look at number 15, and just to confirm that we have the right one, I'm going to look at it again. I keep on forgetting, it is 37. We're going to go in here, toss that in here, and it looks like we went up a little too much, so we're going to go 4 down now. So we're going to go back to automate and 4 payloads down, which is number 11, and we're going to grab this one and see if this gives us number 37, which is the payload we want. And if we go back to our repeater, all we have to do, a replay right here, all we have to do is put this token in there and hit post API. We can hit get API me. That was one of the calls that we saw earlier with the get request, and see that we are hopefully logged in as the role admin with the user ID 37. And that also gives us a flag that we need, which indicates we're in the right place and we have correctly gotten access to the right account. So that was kind of the trick of getting here. A lot of times what I see people give up when it comes down to looking for an account or a way in. Sometimes you can do these with doing mass assignments. You can do maybe some bypasses and things like that. This is one that I've seen work in some cases. all you have to do is hope that there is a div site where they use the same signature for the JWT, and it allows you to sign in there, and you can just use that token to log in into the prod site. Believe it or not, I know it sounds very, very simple, but true story, trust me. So that was the easy part. This is where it started to get interesting, and you kind of had to do a little bit of puzzles, but again, we gave you all the clues that you needed. The whole point of this CTF was to kind of make you look and pay attention to details. So if you did a little bit of reconnaissance here, what you would come across is this files file. You would come across as files endpoint that actually gives you a list of all the files that are on there. There's a name for it right here, for example, and it says index.php. There's a JS file and so on. So it gives you the content type where the filter is, and also tells you, hey, there are this many files on there. So there's found 3 files, and 1 is hidden for security reasons, and you can use the filter parameter, which was your hint, to actually sort through these. So if we go in here, for example, if we do filter right here and we say PHP, it's going to come back and say, hey, there are this many files, but 0 are hidden for security purposes. So that means the file that we're looking for that is hidden is not a PHP file. What you had to do here was get a list of all the different sensitive files, for example, .git, maybe .js, whatever it is, and see which one comes back and says, hey, there is one right here, security is one that is hidden. The answer for this one was an env file. So if you did .env, what you would see is it would come back and say, hey, for security purposes, there is still one file that's hidden. Let me show you the difference. If we do .git, which is not something that exists on this server, it comes back and it says found directories found 3, files found 0, hidden is still 0, versus if you do .env, it's going to come back and say files found 0, but there is one file that is hidden, and you have to guess for it and how to look for it. I'm going to try my best to explain this. It is a bit of a weird thinking process that you have to do. We're going to start with a file that we know it exists. I'm going to empty out the filter here, and we're going to take a look at a file that we know exists, and that is index.php. So I'm going to copy this into our filter. I'm going to say, does index.php exist? We already know that it exists. It says, yep, files found 2, hidden is 0 because there is an index under the folder L, and there is one over here. So there's 2 files. We know there's an index.php and another index.php available to us. With the .env file, you have to take a similar approach. If we do x.php, then it's still going to come back and count index.php as a valid file, because this x.php is a part of the name for index.php, which takes it as a valid file. If we do an invalid letter right here, and we say dx.php, which doesn't exist because there's no files that end in dx.php, it's going to come back with 0 files found. So the whole logic here was, you have to think about the logic of this filter. What is this filter looking for? And it's just looking based on how the file name ends. So if I do index and I remove the in, for example, and I just do dex.php, it's going to come back and say, yep, I found 2 files. They're both there, index.php and index.php in the main folder of files, and then under the directory L. So that's how the logic was. And it was the same thing you had to do with the .env file. The name of the file for the env here, it ended with a W, and if you get it right, it's going to come back and say, yep, there's one file hidden for security purposes, which if I give it an invalid file because it doesn't end with .z, it's going to come back in 0. You can actually automate this very quickly by just going to an automate tab, opening up a session, and for the payloads, we can just do something like sequential and marking. So we know it ends with W. This is the one that we want to look for, so we're going to mark it, and you just have to put the entire alphabet in there. You can find a sample list, whatever it is, you can put it on there. I quickly just imported this by a copy paste from one of my files. It's everything from A through Z here, and then you have every number from 1 to 0. This is what it's going to look for. We're going to start it off. We're going to let it do its thing. You're going to see that everything is going to come up as almost the same. That's not what we need. The length is going to be 4403. And hopefully at one of these, the length maybe changes or something changes where we can find our file name. So now that this is done, we're going to quickly skim through all these. We can see that everything here is 0. We can actually use the workflows here to grep for whatever we want, but I'm just going to quickly, for the sake of the video, show you an example. We're just going to, actually, let me start from the bottom right here. If we go through this, and you can see if I change these at the bottom right here, for the letter K, this changes. So that means if we go back to our test right here, the next word for this is a K. I'm going to do one more to show you how it looks, but I'm going to skip this and give you the file name for it just to make it easier. But now we know K and W are our next one. We can do this one more time. We're going to start it. It's going to do its thing. It's going to come back and give us the next letter. Since I know the solution for this, the next one is going to be actually right here. It is a little bit of a manual work, but then it would suck out the fun if we didn't make it hard on you guys. So if you go down here and you look at the number 8 right here, I'm looking at the wrong one, it looks like. Right here, you can see that it's coming back and saying, yep, security is 1. So the next one on the right is the letter or the number 8. So if you go back here, the next one right here is going to be 8, and you're just going to keep on doing this until you get no valid entries, which is going to give you this file name right here, which I'm going to just go back to replay. Put this here. So what we were doing is we were guessing it from right to left. You could have done that, all of it in one single script, but I want to kind of walk you through and show you how it works. But if you do this all the way, I'm going to just delete the H, for example. You get all the way to 6D8KW. It says 0 files. One more time, if you do the last one with an H, it's going to come back and work. And if you get to an invalid one, obviously it's not going to work. And now that we know this file exists, we're just going to go ahead and fetch for it. Now that we have this file name, all we know is that this file exists, and we're going to just go ahead and throw it in here. And this is going to open up a env file that's going to give you the next flag, but also it's going to give you a backend regex for integrity. And you can see that this is the regex that it allows. I'm not going to explain why this regex doesn't work. Drop me a comment. Tell me, why do you think this regex doesn't work? I think we also tweeted this out a while ago. I think Adam, who created this with me, tweeted this. Let me know, what do you think? Why doesn't this regex validate for integrity.com, and why my solution for the next flag is going to work? Drop me a comment. Let me know if you know the answer, or maybe if you can take a guess on why it doesn't work. Drop me a comment and let me know what you think. And how can you use this to bypass the regex for the next flag that we're going to go after? So drop me a comment, let me know. But for now, let's look at the next step of this, which is finding the endpoint here for our CTF, which a lot of people lost their mind over this because for some god-awful reason, nobody in the InfoSec community, bug bounty community, had the keyword webhook in their word list. I look at SecList, I looked at a ton of different ones. Even Zayed and I were looking just to see if we can find webhook anyway. He was still stuck on this. I'm going to actually throw him under the bus and talk about it. He was actually confused of why can he find webhook. And when we did a research afterwards, we realized that a lot of these word lists for some reason don't have webhook within them. So if you don't have it, throw it in your word list because it may come in handy, for example, in this CTF. But you can see right here that webhook does exist. Again, a lot of people missed it. And this is where the regex come into play. When you discover webhook, it's going to come back and say, hey, the query string is missing. You have to do a little bit more of content discovery. But if you did a little bit of brute forcing, you will see that the URL actually is a parameter that's missing. And if you give it a URL, it's going to come back and say, hey, this is not a valid host, and I can't take what you're giving to me. Well, it looks like it actually takes google.com, and it works. Actually, if you do google.com, it does work. Sorry about that. But if you do something like a local host, this is where it gets interesting. It comes back and says, nope, content is false. But the trick here was to connect it to, if it allows integrity, and integrity was the sponsor for this video, I wonder if we can use that in any way to bypass the regex and point it to an internal host. This is the whole concept here, is how do you point this into a local IP address, or what host do you even give it to? So the first step is always with an SSRF is to point yourself to local host, and you can easily do that by just doing a DNS rebinding or using some of these DNS tools that allow you to do this. So for example, if we go back to our regex really quickly, we know that it works with anything that ends in integrity.com. But that's the trick. It's not exactly that. It actually allowed you to do anything that had integrity.com inside of it. So I could just do something like 1.integrity.com and then point it to 1.0.127.0.0.1 nip.io. And if you're not familiar with nip.io, it just allows you to point any of their subdomains to any internal IP or external IP address that you want. So for example, if you want to do 127.0.0.1, you can just do it in this format. You can put everything before the IP address with a dash, or you can just do it with a dot as well. So in this case, what we're doing here is we're just going to point this to 1.integrity.com. This could be anything, I think. It could be 1, ABCD, whatever. As long as it has integrity.com within it and it points to 1.270.0.0.1, it's going to come back and give us the flag that we want. And it says, hey, by the way, there is a /git check here that needs your attention. And again, as we progress through this CTF, I feel like it got harder and harder, and a lot of people were just getting more in depth and overthinking a lot of these. But all you have to do for this one is hit the git check, and it will come back and tell you, hey, there's a missing ID parameter. We'll give you the ID for it. And if you do ID equals to 1, it comes back and says job is already set, and it's set as complete. this is where it gets interesting. A lot of people understood the assignment here and they found the SQL injection. But what people missed here is, what was the purpose of the SQL injection? Shout out to Tips. He wants me to say SQL as I say SQL injection. But so if you got the SQL injection, what are you supposed to do next? So let's look at that really quickly. What you have to do here is, it's a very straightforward SQL injection. You can exploit this very easily. It's going to come back and give you an error. Honestly, we didn't expect you to spend too much time on this because all you have to do was do a union select 1, 2, 3, 4, whatever the numbers are, the 3 columns right here. It's going to come back and say missing HTTP scheme, and it just kind of points you to saying, hey, something is missing here in the HTTP format. And if we actually pass to something with HTTP in it, so I'm just going to do www.nahamcon.com. It's going to come back and say, let's do that one more time. We have to close this actually. It's going to come back and say, hey, invalid response expecting JSON format. That means that it's sending a request here, but whatever we're sending it to, it expects it to be a JSON response. And I think this is where a lot of people missed the point. The hint here for this level was that you have this endpoint called getCheck that's doing something with Git. And if you're sending it the URL right here, it's making that request to that website and it's coming back. There's a ton of hints here, starting with this right here that says, hey, there is an HTTP scheme missing. If you do a website and if you didn't do the slash, it would actually tell you, hey, this is the wrong URL structure. But if you did a /1 or anything like that, it's going to come back and say, hey, invalid response. I'm actually expecting JSON for this. So what you can do here is open up your interact sh, give it this URL. I just did this before I actually launched this, but we're going to do it one more time. If you put that here and you send this request, it is going to make a request to that server. But what's really important here that I think a lot of people missed was, even though it says invalid request, it's coming back, it's making that one request. It is actually leaking the bearer token for a GitHub repository. So this application, what it did was, whatever you inserted into the SQL injection, whatever URL you were doing, it was replacing it with the GitHub repo that it had access to. And all you had to do was get this flag, which you can solve now, you have the flag for it, and get this bearer token that is an actual valid token for a GitHub repository that you can log into that gave you access to the entire application. And obviously the next step was to do some code review, maybe crack some stuff and get the final flag, which I don't want to ruin the CTF. So if you want to finish this, this is your last thing you have to do. Go through all the steps that I talked about today, get to the final step, get access to the source code, download the source maybe, and do a little bit of code review. It's super easy. All you have to do is maybe do some raw queue usage and find some things and then get access to the last flag. But that was kind of the gist of this whole thing. We wanted to kind of make you think about SSRF. We want you to think about things like SQL injection, doing authentication vulnerabilities, but also make a little bit of scripting and recon involved in the whole process. I genuinely enjoy making content like this, or even actually making CTF levels like this. I don't know about you. I don't know if you enjoy it. So let me know. Drop me a comment. Let me know if you want to see more CTF solves from me. If you want me to talk about some of the CTFs that I have done in the past or I've created, drop me a comment. Let me know. This was an exception. It was in partnership with Integrity, and I honestly really enjoyed making it with Adam. So I figured, why not make a video out of this and let you guys kind of see the solution and maybe push you towards wanting to solve this for yourself and putting your actual skills to a test. All right, that's it. Thank you for being a subscriber. And if you're not, it's not too late. Hit that subscribe button, become a Nahomie, and do all the liking, do all the commenting. And I will see you all in next video. Peace.